Hello and welcome to today's webinar, How to Specify a Maintenance Inspection Window. My name is Rudy Woodridge. I'm the Vice President of Engineering Services at IRISS out of Bradenton, Florida. Today's webinar will cover how to write a specification document and what to consider when writing that document for a maintenance inspection solution, so that could be an infrared or ultrasound listening port, on your switchgear. We'll also cover how to do this when you're looking at arc-resistant switchgear designs. So let's start with a little bit of background information. Infrared windows can only measure the temperature of objects that they can see. Right? You cannot perform infrared directly through an enclosure door or panel. You can't use infrared, will not transmit through metal. An infrared window allows infrared cameras to see components and connections inside the electrical equipment while keeping the covers and the doors in place. And this, of course, is the safest way because you're maintaining the equipment's closed and guarded condition at all times, and you're eliminating any risk of electrocution or arc flash. Infrared cameras cannot see through glass or through most plastic materials. So the viewing panes that you may have existing in your switchgear that could be made from Lexan or something similar to that are not feasible as a means of performing infrared inspection. Infrared energy will not transmit through these materials, and essentially they give you nothing but a blind spot. You may be able to see through them visually, but you cannot see through them and get accurate temperature readings of any kind whatsoever with an infrared camera. And finally, infrared window lens materials are typically specialized infrared transmissive polymers or fluoride-based crystalline materials. So these are kind of the two standard options that are out there, and we'll talk about those at length. Well, why should your viewing window only perform infrared inspections? There are many other types of inspections other than infrared that are routinely carried out on your electrical equipment and for which you require safe access. This could include airborne ultrasound inspections, motor current analysis, partial discharge testing, corona inspections using UV cameras, power quality monitoring, visual inspections, all of these. So therefore, we shouldn't specify just a maintenance inspection window that is only for infrared, but rather one that can handle all of the different condition-based technologies that exist and that can help you assess the health of your assets. So if you're going to the trouble of installing and specifying maintenance inspection windows, there's a huge investment that could be involved in this, both in terms of time and energy, but also money. And you want to be able to maximize that return on investment. If you're limiting the scope of the device that you're installing to only perform infrared inspections, you're really missing out on a huge opportunity to maximize your ROI. So we recommend that a maintenance inspection window should allow all inspection types to be completed by all of the equipment that you intend to use in that closed panel energized inspection mode on your electrical systems. So maintenance inspection systems allow closed panel inspections, and they should do so in the visual spectrum, the infrared spectrum, as well as the ultraviolet spectrum. UV can be used for detecting corona on medium voltage equipment. They should also, if the customer wants, include the ability to perform ultrasound or partial discharge access. And they come in different sizes and shapes. They're available in round, rectangular, and custom-built solutions. Here we see an example of a custom solution. In the custom solution, the original panel is taken off, removed, discarded, or recycled, and it's replaced with a unit where the infrared window has been built straight in. This allows the customer to do the installation much faster as there's no cutting or touch-up painting required. It's simply a matter of removing the old panel and adding the new panel in its place. In addition, these units can provide an access point for future maintenance. So not only does it become an inspection point for infrared, ultrasound, ultraviolet, visual inspection, but it also becomes a point of maintenance access. So how should you think about specifying a window system for your new equipment or retrofitting an existing equipment? There are a number of specifications and certifications that a maintenance inspection window should meet. You need to consider field of view, in other words, the area that you will be able to see, window design parameters, viewing lens material, relevant certification requirements for your particular application. And of course, window performance specifications over time. You want to make sure that you're buying a solution that will work for not just today and tomorrow, but for years into the future. Warranty is critically important, especially given some of the material limitations that some of the viewing lenses have. So let's talk about each of these different points in greater detail. So first, let's talk about field of view, or FOV. So the field of view calculation is based on the viewing angle of the camera and the equipment using the system. All right. Full consideration has to be given to internal obstacles inside the equipment. That could include phase dividers on circuit breakers, internal cable routings, as the cables may interfere with your ability to see the actual targets, as well as the physical designs of the doors and covers. We have to worry about the doors being reinforced, double thick, having internal covers that may act as barriers, where there may be push buttons or switches that are mounted on the door and that limit our ability to mount the window where optimally we'd like to mount it. So all of these need to be factored in when we're looking at the field of view. Now every camera is slightly different, but the average camera has a field of view of 22 degrees in the horizontal and 16 degrees in the vertical. Now, using that information, there's a formula that will help you derive what size of window is necessary based on the size of the target that you're looking to be able to view. So how does that work out? Well, basically, we have the window size, which is the thing we're trying to derive, both its width and its height. So we have to do two different calculations, one for width and one for height. We have the target size, where we're inputting the width of target or the height of target. And then we have the camera viewing lens angle. So again, we're using the viewing angle for either width or height, depending on which calculation we're making. And then, of course, the distance from the cover where the window will be mounted to the target in question. All of these come into play, and we're able to then calculate the minimum window size, its width minimum, and its height minimum in order to see a target in question inside our electrical equipment. So let's go through a sample calculation for field of view. So let's say we have an enclosure with the distance from the cover to the internal components that we want to see, which is 8 inches. And we have an overall target width of 18 inches. So that might actually be the width from the A phase connection that we want to see to the C phase connection, and include the center phase connection as well. So to calculate the minimum window width required to see the targets using a single window, we would use the formula and input the target size of 18 inches, the camera angle in the horizontal of 22 divided by 2, and take 2 times the tangent of that, multiply by the depth to target, and by a factor of 3. All right, so what that comes up to is a minimum width of window of 8.66 inches. If all that math seems too complicated, the good news is that we do have a window sizing tool that you can use. So step one of this is you confirm that you've got the right camera angles, and we have different tables in here that also with different cameras. Then you add in the height of the target, the width of the target, the depth from the door or panel to the target, and it outputs for you the required minimum window width and window height. It also recommends from the IRISS catalog a window for you. If a round window will work, it will recommend one. If it's too large of a target for a round window, it will recommend a rectangular window for you to use. So as far as the specification goes, we need to look at a few different things. The inspection window assembly itself should comply with the testing standard requirements for flammability, impact, and load. Flammability is important whenever there is any kind of plastic or polymer material used in the window construction. It should comply with the OEM specifications for materials and color. So it could be aluminum, steel, stainless steel. The color should match the OEM original equipment as closely as possible. As far as the inspection window lens cover, it should be attached to the window and not removable to prevent the cover from being lost or misplaced. There are designs out there where the covers are removable, and very often we go out in the field and we find that they've been lost. And without the cover in place, the window has no protection for personnel walking by for any kind of arc flash event that might occur. And the window lens cover should also have a normal position for the cover which is closed for a fixed and guarded condition. In other words, it should state directly on the cover that the window should be closed during normal operation of the equipment and only open during an inspection. Finally, you may also want to specify a lockable option on the window cover. If the equipment is going into public areas, that can be very important to ensure that there's minimal risk of anyone interfering with the equipment via the window access point. Now, as far as the window lens material, we also need to think about that very carefully. It should be able to withstand all mechanical, impact, and static load test requirements with the cover open. There are some standards out there that talk about testing the window with the cover closed. However, we don't prescribe to this. It should have a fixed and stable transmission rate for the entire life of the unit. In other words, the transmission rate of the optic material should not change over time. It should not be subject to contamination from water or other materials that might be in the atmosphere that could cause the transmission rate to change. And there are some materials out there that are used where that transmission rate will change over time, and so you can specify that you will not accept something like that. It should be able to transmit light in the infrared, visual, and ultraviolet wavelengths so that you can do all types of inspection through the window. As far as the infrared radiation, it should operate in the mid-wave and long-wave frequencies from 3 to 12 microns, because that is where virtually every infrared camera is using infrared detectors to pick up the heat energy coming off of your targets. It should also be able to withstand prolonged exposure to vibration without any risk of cracking or degrading. So this kind of precludes the use of many crystal type materials because they will crack just from slamming the enclosure door, or from equipment vibration they can be exposed to and crack or break completely over time. Furthermore, the window lens material should be able to withstand prolonged exposure to direct sunlight without any degradation. This is very important for outdoor applications. It should not absorb moisture such as water. In other words, it should be non-hygroscopic, meaning it should not absorb water vapor from the atmosphere that can contaminate the lens material and cause a degradation of transmission rate. Any design, in our opinion, should be an IP2X fail-safe design, which basically means that nothing smaller than a 1/2 inch or 12.5 millimeter rod can be inserted through the window at any time, whether the cover is open or closed. It should be able to withstand temperatures up to 250 degrees Celsius, because we can see with loose electrical connections the temperatures get very, very hot. It should be resistant to light acids, alkalis, and water. And the material used should be non-carcinogenic and non-toxic, and should not contain anything that could enter into the food or beverage or pharmaceutical stream of manufacturing. So that eliminates many materials that are sometimes used as the optic material for an infrared window. So let's talk about the actual certification requirements. There are many relevant certifications that we should be looking at. In North America, we have UL standards. The UL standard 50V is the standard for infrared viewing ports. So any device that you're purchasing would typically and should have compliance with UL 50V. There are also the environmental certifications. The UL 50E is environmental testing, basically testing the ingress protection rating of the equipment. We have NEMA ratings in North America. There are equivalent IP ratings for the IEC market and most of the rest of the world. And the devices that you're specifying, you can specify the IP rating that you feel is appropriate. NEMA 4, NEMA 6 are typical. That would be IP 65, IP 67. You also want to look at UL 94, the 5VA flammability test. And this is important on any, again, windows that have any kind of plastic or polymer material as part of the assembly, whether that be the lens or the body. The UL 94 test is a flammability test, right? And it's for all switchgear rated plastics must undergo this test. And so if you are utilizing an assembly that has any kind of plastic material, look for that from the manufacturer as well. Furthermore, any windows should be able to withstand the relevant impact and static load tests with the covers removed. And there's a couple of standards here that are relevant. One is for low voltage equipment, which is the ANSI UL 508A, and then in addition, it's the UL 1558, and then for medium voltage equipment, it's the IEEE C3720.2. And finally, there's also the UL 746C standard. So all of these talk about static load and impact test requirements on the IR windows. And you should be specifying compliance with these standards as well for your designs. For Canada, there's an equivalent standard, the CSA C22.2. Now, what about if this is a marine application, on a ship, on an oil and gas platform, anything like that? There are marine certification requirements that are very specific to that segment. They could include the Lloyd's of London approval, the ABS approval, or the DNV approval. So if you're doing a marine application, you should look for at least one of these certifications on the equipment that you are specifying. You should also be specifying the applicable temperature range in which the equipment will operate. All right, so you can specify what the ambient temperatures will be in your application, and you can clearly specify those up to 100 degrees Celsius. Now, arc containment testing. This is a big, big topic. There's a couple of standards for arc containment testing. One is the IEC 62271-200, which is for testing metal-clad switchgear. And if you are doing a European design or you have European designed equipment that meets the IEC 62271 standard, you should be specifying IR windows that will pass that type test. All right, and it is a type test. And what that means is that really you need to have the equipment tested with the window fitted and revalidate that the equipment still passes the flame test requirements that are embedded into that standard. The second type is for arc resistant switchgears, which is more of a North American standard, and it's the IEEE C3720.7. And that standard is also a type test, which basically, again, means that you must test the switchgear in question with a window fitted, and it must pass that test if you want to be able to offer, as the OEM, that equipment for sale with the window as a standard option. All right, so what do I do if I'm specifying new arc resistant switchgear? Well, you can specify it with windows, but the OEM may have to perform incremental testing if he has not done so before with the window fitted, which is a bolted fault test. It's a destructive test of the equipment. But once he's done that, he can then offer those infrared windows or maintenance inspection devices as a standard option going forward. So there is a cost for the OEM, which may have to be incurred if they've never done it before with that particular device. All right. Now, what about retrofit situations of arc resistant? Well, this is a very touchy subject. My personal recommendation is that if you have existing arc resistant equipment, you can contact the OEM and ask them, have they ever fitted infrared windows and retested? What window would they recommend that has already passed those tests? And you could retrofit that solution. Or if their answer is no, we don't have any window that we've ever tested with this arc resistant design, then you are kind of in a bad situation. There is no real good solution for that without invalidating the arc resistant rating of your gear. Now, that being said, we have fitted our infrared windows in many instances, both the VP round series and the cap rectangular series, into arc resistant switch gears and had them retested, and we have never had an instance where the window failed, window caused the test to fail. All right, so the reality is that yes, you could fit a window and you would likely still be fine as far as passing any arc resistant tests, but really that test should be performed by the original equipment manufacturer as part of their design validation process. So it's not a great answer, but it is what it is as far as what to do in these situations. So carrying on, you should be specifying the infrared lens transmission rate that it be stable and fixed over the entire operating life of the solution, of the maintenance inspection solution. You should ensure that the inspection equipment is compatible, right? That any window that you're deploying is usable with all makes and models of focusable IR cameras, including cameras with dual visual and digital infrared capabilities. You must have visual inspection capability. An visually opaque window is no good to you if you intend to also use it for visual isolation verification and for visual inspection of other components inside the enclosure. And it should also be compatible with all makes of ultraviolet cameras. Finally, all provisions for ultrasound and partial discharge testing must be IP2X compliant. So if you are asking with that maintenance inspection window to have capability to perform airborne ultrasound, that should also be IP2X compliant, meaning again the half-inch rod, 12.5 millimeter rod test is passed. You cannot pass a rod of that diameter or larger through the grill that's involved in performing the ultrasound. Finally, warranty. You can specify your warranty conditions, and there are windows available from IRISS and I think from others that carry an unconditional lifetime warranty. So an inspection window manufacturer should be able to repair, replace any inspection window or component with the same or a future generation model if the product has ceased to perform to the end user's expectations for any reason. That's truly an unconditional warranty statement, and that's the statement that we recommend you embed in your specification. It should be that for the entire life, there should be no exemptions, right? There should be really no reasons why the manufacturer would not stand behind their product. And the only case would be if they're using it in a temperature rating, for instance, where it wasn't rated for like a high temperature oven application or something like that. There are very, very few reasons why an IR window manufacturer should ever say, nope, you're not covered under warranty. And we have a very, very liberal warranty policy, and basically we carry an unconditional lifetime warranty on everything that we manufacture. Now, when you're asking the original equipment manufacturer for maintenance inspection solutions, you need to be very specific. You need to identify the internal targets that you want to be able to inspect. What do you want to be able to see? So that should include the breaker connections, both the line and load side, incoming cable lugs, fuse disconnects or contactors, the connection points on those, bus bar transitions or bushings on transformers. All of these are the things you want to see. Then you may also want to on critical components. So for instance, if you were specifying a maintenance inspection solution for a variable speed drive or an inverter or something like that, there are some critical components you might want to see. The DC bus capacitors, the IGBT connections, all of these are points of possible failure. And then, of course, you have to specify to the OEM the types of inspections you're going to do. Oh, I'm going to do infrared. I'm going to do ultrasound, airborne or structure-borne. So I need test points, right? I want to do transient earth voltage detection. So I need to have test points identified where I should be testing for that. I want to do visual inspection. So my window needs to be visually transmissive as well. And maybe I want to do ultraviolet on my medium voltage equipment. So all of those things are specifiable, and you should be driving that exercise. So let's recap. What are the benefits of using maintenance inspection windows? Number one, we're removing the high-risk behaviors associated with open panel energized inspections of your electrical equipment by maintaining everything in a closed and guarded conditions at all times during the inspections. We're able then to do the inspections under full normal load conditions, which is when we're going to get the most value from doing these types of condition inspections. We can't do them de-energized. We can't do them under low load conditions. We need to do them under full load, normal load conditions. We're able to access inaccessible equipment. There are many types of equipment, panel boards are notorious, which are so difficult to do infrared inspection on. It's a three-man operation to remove the front panel from a panel board in some cases, and it's time consuming and it's dangerous because you're doing it on energized equipment. You'll be able to perform much faster inspections. When the maintenance inspection windows and ultrasound ports are embedded in your equipment, a single person can go walk around the facility in no special form of personal protective equipment, and they can do the inspection in a fraction of the time that was required before, when you were opening doors and panels and having to wear full PPE, arc flash suits and hoods, etc. Much less manpower is required. Again, one-man operation versus a 2 or 3-man operation when you're doing energized and open panel inspections. The lower PPE levels, it is uncomfortable to work in a 40 cal suit or a 60 cal suit. You can only do it for so long. You have to take breaks because you're going to get exhausted from doing so, and it is cumbersome, and it's very easy to make a mistake when you're working in that heavy PPE. You can drive an increased inspection frequency when you have the windows in place. And by increasing the inspection frequency, because it's so less labor intensive, it's easy to do it, right? And you can do it more often, you will catch problems earlier in the PF curve and have the ability to then take corrective action decisions much sooner, which will drive lower costs of repair on any problems that you do find. And you'll have a much better return on investment using critical asset surveillance technologies, equipment, and the training for your personnel to do it properly. So summary. All maintenance inspection windows should allow for access of all types of condition maintenance equipment. So infrared, ultrasound, visual, etc., etc. Maintenance inspection windows should have flexible and customizable design options to meet your client's requirements. A 3-inch round window does not work in every installation. You must have the ability to do rectangular, to do custom sizes, to do custom replacement panels. All of these things are available today, and you can specify them. A maintenance inspection window must hold all the relevant certifications for the markets that you're going to be using them in. And we do have sample specification documents that we can share with you that I can provide, Doug can provide to you, and you can utilize those in your marketplace for helping drive specifications on new designs or in retrofit situations for your clients. And finally, a maintenance inspection window must meet or exceed the mechanical and environmental testing requirements of the OEMs and the relevant certification bodies. So thank you very much for listening to our webinar today, and now I'm going to open it up for questions.